Hello guys, welcome back to my YouTube channel. Let's do one more exercise from sheet metal concept in catia software. So see, my views are projected here, isometric views there, and this is called the deployment view or flatten view. So right, so if you see these orthographic views, you can understand that it is easy to model it from the front view. So for that I'm making this model from the front view. So let's go to software, click on the start, mechanical design and generate a sheet metal design, give its name, click on OK, and after that click on specify the parameters first. 2 mm is the thickness and 2 mm is the bend radius, click on OK, click on the position sketch, select the front plane, click on OK, and then let's make one profile like this. Right, now give the dimensions. What about dimensions? 84 it is, 104. This line which is about 84 divided by 2, that is 42, and from here to here which is about 104. From this point to this edges 104 divided by 2, that's it. From this line to this line, so how much it is? 46. So you need to keep in your mind, so you have drawn a sketch, so based on this sketch your sheet metal should be in downside of this line, downside of your sketch. So that is the thing that you need to keep in your mind. So click on select the present, hold the control key and select these three entities, use the mirror tool and choose the mirror line, that's it. Exit, use the extrusion tool, let's make the extrusion of 25 and click on the mirror extrusion option. The entire extrusion is 50, I have specified only half value. Click on preview, click on OK. See, the base is completed. Now talking about this one, so what I'm doing, click on the wall on edge option and select the edge where you want to add that wall, that's it. So what about the angle is 90 degrees, that is okay. Now what about height? The height is specified here 42. So 42, click on preview. So here you can see our wall is extended from where to where, from here to here. And if you see here, see, if you see clearly, this is our wall and wall is somewhat inside of this base edge. I don't want that. I want this wall completely to be outside of this flange. So what I have to do is I have to specify the clearance mode. So monodirectional and 2, click on OK. See, now it is okay. And one more thing is, this is not throughout this length, this wall is not throughout this length of this base. So that is, you can see here, so which is about 62 only. So for that what you have to do is, so from here to here it will be 32. So what I have to do is, so there is no proper way to make the right dimensions properly. So for that what I am doing, and click on the sketch bezier and choosing the sketch and this plane. Click on the corner rectangle like this. Click on the dimension constraint, select this line and select this line, make sure it is coincidence, and select this line and this line, right click, yellow symmetry line. This process will give the symmetry relation between these two lines and this length and this length, so which is about 62 and which is about, this is about 46. And right, exit. See, wall is created. See, these not, so the clearance mode is not applied here. So So click on this monodirectional and update the value as 2. That's it. Now the next step is just add this wall by using the wall on edge option again. So here also see 62 is total length, and from here to here, which is about 24, and 62 minus 24, 60 minus 20, 40, 42, 40, 38, right? So what I'm doing is select this edge, set it to automatic, and this is about the extremities. So keep one as 0, preview, and keep one as minus 38. Click on preview. See, this is how you can calculate. But what about this length, which is about 14, that is 28. The height is about 28 only. Click on preview. That's it. Click on OK. Now let's make a one cutout here, circular cutout. For that, choose the position sketch and let's make a one sketch here. Diameter of the circle is 13, and from this to this, which is about 12 only, and from this to this, which is about 14. Exit, cutout, make sure it is up to next, preview, OK. One more cutout I need to make. Click on the position sketch, select this plane, click on OK. Let's make a one circle rectangular cutout like this. Dimensions, right. Now say about the dimensions. This is about 20, 25. So this is about 20, enter, and this is about 25, enter, and 4, 6. So this is about 4, and this is about 6. That's it. Exit. Use the cutout option again. Up to next. Click on preview. Click on OK. Click on the wall on edge option again and select this face, and make sure the extremities are 0. Preview. See, it is OK now. So let's see about what is the clearance. What about how much is the clearance will be? So this clearance, so 10 from the center point of the circle to the edge is a 10.5, and that side also will be the 10.5. That means 10, 10, 20, 21, which will be from here to here, and 2 mm is difference. So what I'm doing, minus 2 extremities I am specifying as minus 2, minus 2. Click on preview, click on. And what about height? So what about this height? So see, the entire height is 20. So here you have to calculate it. So right now I'm just keeping as 21 approximately. So that will be not enough. So keep it as 18 only. Click on preview. 19, preview. Okay. Right. So click on the position sketch again, select this face, click on OK, and let's make a one circle here like this. From the center point to this, which is about 10.5, enter, and radius, what is about diameter of the circle? 7, and about this 5. from this center to this, which is about 5 only. That's it. Exit, cut out, up to next, okay, that's it. So from the starting itself, I just forgot you to reveal an important thing that you need to keep in your mind while designing a sheet metal part. So every time, so it is a CAD modeling, so we are directly design this component with these bends. But in the manufacturing process, what will happen, they take a plain sheet, and from the plain sheet they will cut the portions whatever they want based on the dimensions, and from that cutted piece they will bend these walls. So that is how the sheet metal parts will be manufactured. So when you are making a sheet metal part in the modeling software, so not only in CATIA, so any modeling software, when you create a sheet metal part, it is always required to make this sheet metal part into a plain sheet. So for that there is an option called flatten option is given in every software. So but in the CATIA it is shown as unfolding. So if you click on this, select all, and if you choose a one base plate, click on preview, click on OK. See, this is how. So this is the flat portion of the part that we have made. So while in the manufacturing process, they will cut a sheet metal part with this shape, and after that they can only bend these walls, so according to our 3D model. So when you after creating your 3D model, if you are not able to make this flattened portion, then the manufacturing process won't work. Your design will be having some errors. So that's why you need to design the sheet metal part in a way you can unbend or flatten the every phases of this sheet metal. You have to design likewise. So that is the one thing you have to keep in your mind. And another thing is, what will happen, so we have a simple option called unflatten or flatten to make our bended part into a flat part. But in the companies, when you go for interviews, what they ask, they will give you or else they will give you a flat part, and they will ask you, or else they will ask you to make a flat pattern based on your own calculations. Or else how they can ask interview questions, they will give you a bended part and ask you to unflatten it, so based on your own calculations. So in next video I will discuss about those things. There is some 2 to 3 formulas will be there. By using those, you can convert a sheet metal component, sheet metal bended component into sheet metal flat pattern. So this is how the sheet metal parts will be designed. So if you find anything helpful in this video, and if you like our content, so please do subscribe to our channel.